I'm Martin. I'm, as said, director in IT, and as such, in my department, we are 5 teams, roughly about 60 people, and we are developing custom-made applications for our business colleagues and also for our customers in the end. And there are several teams or departments next to my department, reaching from booking to sales, or from sales to booking to the operational execution. And yeah, so me and my teams, we are developing applications around equipment, which first and foremost are those metal boxes you see there on the vessel. And we usually call them containers, so it was quite easy catch to say, okay, it came quite naturally to join here on the ContainerDays. So today I'm going to tell you how to building an IoT and data ecosystem for one of the largest container fleets in the world. And usually I have support from a dear colleague, my AWS solution architect from Global DataNet, Jarko. He's not here, so I try to do it on my own, so bear with me. It's not just about the containers on the vessel, but we do some cloud stuff as well. We have nice pictures of our ships, and we also have an architecture diagram, so hopefully there's something in there for everybody late in the day. So Hapag-Lloyd is one of the largest ocean carriers in the world, and I nicked a slide from our corporate communications department, pretty nice and orange. And there are 2 numbers that I want to draw your attention to. So actually one fact, for those who are in Hamburg, you might know that we are located here in Hamburg. We have the headquarters at the Binnenalster at the Ballindam, named after our founder. And yeah, it's nice place to be. But there are 2 numbers where I want to draw your attention to. First and foremost, there's the 1.7 million physical steel containers that we have. It's necessary later in the talk, and first and foremost, the number is not correct. It's actually 2.2 million, or will soon be 2.2 million, so we are growing, and our corporate department wasn't quick enough to update that slide. The second number I want to draw your attention to is the fact that we are active in 135 countries, meaning we offer our services around the world. We operate there, we operate globally, obviously. And the service we offer to our customers is not just, as you've seen, port to port via the oceans with our vessels. No, it's actually a door-to-door service that we offer. That means we also organize for our customers the inland or hinterland transport, for instance, from the factories across the oceans to distribution centers. Yeah, so if you order a container transport with Hapag-Lloyd, we bring it from door to door if you wish. So we do operate our vessels that are ours, and those of you here in Hamburg may have seen the nice black ones on Elbe River. But the hinterland transport, the inland transports through truck and rail, they are done by our subcontractors, by our vendors. Sometimes customer organizes those transports themselves, but again, we offer that. And even though we know where we ordered for our customer, so we know which trucker we asked to transport a container, we do not necessarily know in any point in time where the container and thus the cargo of the customer actually is. Let's have a look at an example. So for those that are still in the summer mood, we look at the nice coast of Spain, we look at the port of Barcelona, and we have one of our vessels arriving at the port, and now it discharges many of the containers. And if you've seen the pictures, it's quite big vessels, there are quite a lot of containers on there, so presumably many of those will be discharged at the port. Now, once we ordered a trucker to bring, let's say, some containers, some football equipment to Madrid, right? So once the truck has left the port, we actually do not know where it is in that moment in time. Presumably stuck in traffic somewhere in Spain, and if that happens, we do get sometimes inquiries, or often, by our customers. So they want to know, where is my cargo? When will it arrive, and in which condition is it in? In these cases in the past, once a customer called one of our colleagues, they in turn had to contact the specific trucker or the specific rail company, asking about the whereabouts, okay, with that specific transport, where it's actually at. And then they revert that back to the customer. Quite a tedious process, lots of communications across different teams internally at Hapag-Lloyd as well, but also from the customer through us to the vendor. So not a very nice situation. But it's not just the customer there, it's also for us internally quite interesting to see where our equipment and the cargo of the customer is. This information is very helpful. For example, it helps us to plan and optimize the utilization of our container fleet. So we actually have an internal KPI targeting the productivity of our container. And we have to buy these containers, these nice orange ones, and operate them to most effectively. So if we now know, for instance, when a customer will return a container, or better yet, when it will arrive at a depot, and it's already on the way back to the depot, we can already plan and promise this container to the next customer. Now, to get this insight, this improved service quality for our customers, giving them insights when they can receive their cargo, as well as for us to get the insights to optimized, we had to do something, and we set ourselves the mission. And we set ourselves the mission to create the world's, or to build the world's largest container fleet. And that meant we equipped them with tracking devices. One of them you see up there, one of them I have here, so my boss can track me right now where I am. This is how they look like. They are custom-made for Hapag-Lloyd. We have several different kinds of those from several providers. And we equip them to our 2.2 million containers. These devices track, so you see they actively send. I would ask if they do some RFID stuff. No, they are actively sending, and they send the position, they send the impact, they send temperature, humidity data, actually some time as well, and then can do some alerting. Yeah, first of all, it was quite a bit to install these devices because, again, imagine the number of containers, and secondly, they are moving around the world. So that was quite a logistical task to get that done. But we have a logistics provider, we have some specialists for that. Yeah, all these devices are now sitting there on the containers, and all this generated data also needs to be ingested, processed, and somehow put into context to actually create the value for us internally, but first and foremost also for our customers. And that brought us to our second challenge. We had to build an IoT platform that was up for the task. And there it is. I have my system diagram. It became clear that for this purpose, we need a specific architecture. It must be very scalable and very elastic. Now, why is that? Again, the number of containers we record currently every 15 minutes, the GPS position and other sensory data. And we send that to our backend, and we send it from all over the world. That means we currently receive about 16 million messages per day or 500 million messages per month. And first and foremost, as I said, we got different hardware providers. So we had to integrate them, and we integrated it via an API gateway in our cloud infrastructure. There's already a validation there, basically about the permitted values that are in the different data fields to give some basic data quality, ensure some basic data quality of the data that we receive. It is also important to note that the data does not come necessarily regularly. Because if you can imagine, even though recorded every 15 minutes, there are areas in the world where we do not have the proper network coverage. As you can easily understand, if we are on one of those vessels in the middle of the ocean, the next O2 network tower is quite a bit away, so we do not receive the data at that point in time. So once our vessels reach the port, there will be bursts of data. The containers get unloaded, they get connectivity, and they will send all the cache data to us. And we have data bursts that can amount to double the data volume per day. So we had some measures around 37 million messages per day. One part is the performance and the elasticity, but also when we created the architecture, we also had to look a little bit about the costs. Again, me and my team, we have cloud engineers, cloud architects in the team. We have obviously the application developers in the teams and the business experts. We have the product owners, as you've heard in other talks, so quite a standard setup. But we work very cost sensitive as well. So we've seen somewhere the buzzwords of FinOps. So we looked at it and said, okay, how much will that cost and what can we do to manage the costs? Because we, as you've seen, we are growing, we get more containers, we increase the frequency. Prior it was just 1 hour, now we have every 15 minutes. So there were new requirements coming up that also affected the costs that will arise from that. So what we did is, lambdas can be sometimes, I think, a little bit costly. So to cater for that, we have there in the ingestion on the left-hand side the kinesis, and actually we used a little, not a technical trick, but when we talk about our live monitoring, we have big containers, we are in the heavy industry, so it's not about seconds, it's more about half hours or 15 minutes. So having there a little bit delay in the processing is not really the problem. So we sort of batched the data together in order to have it then processed through one lambda in a batch and then push it into our time stream database. And that ended up, our lambda course we put in here, I feel colleagues are quite proud of it because they've seen other setups and maybe you have some experience as well. So they're quite happy that we are around $45 per month. So I think negligible at that point for us. We have also the same batch processing when we distribute the data further to our consumers. So we have our data lake, we have AI applications, and they can subscribe to our Kafka, and also there we write them in this batch modus into the Kafka to do not create too many lambda transactions. There's a third way, not a third way, but we also sometimes encounter the fact that we get historic data, quite old data, and the time stream database, which will enable us to get efficient querying of this kind of data. So for old data, they run over the top into a batch processing that sort of first collects data and every half an hour sorts it in a timely manner, in a time sequence, and then pushes it to the time series database or time stream database. We have, of course, because the consumers are internal consumers on the lower right-hand side, we obviously have our customers and our users who want to query for a certain transport, the whole sequence, where the container was, where it currently is. So in order to allow for that, we have a private API gateway in our infrastructure, and that enables then for the Lambda the efficient retrieval from the data from the timestream database. Yeah, so that enables us to get quite short response times. If we consider this in the context of our web application, our customer-facing application, there's not just the retrieval of our data, but there's also the retrieval of other data provided to the customer to see about the whereabouts of his cargo or her cargo. So it's important to have here quite a high performance when retrieving that kind of data. And currently, this infrastructure did the trick. Now, how does it look like? We've seen the port of Barcelona in the example, and we did some different querying, not looking at one transport, but made a snapshot in time. And suddenly we see where our containers are and where they're going. And there they are. This is an insight that prior to our project was not available to us. We knew where the containers and the ships on the sea are, but we do not know once the container hits the hinterland, the inland, where it actually is. Yeah, and we see some of them made it to Madrid, so hopefully they got their football gear. Some of them went to Logroño, I think Pamplona, there's Zaragoza there. Potentially some went to Perpignan, to France as well. Now, we get this unprecedented insight from our IT tracking, and we offer this transparency now to our customers. It's available, I think, since April, where the customer can purchase from us. Actually, it's for free. We are that generous to see where his or her cargo currently is on the hinterland. And it also gives us the better insight for the planning. As you look at the picture, maybe one of the other person here gets creative and say, oh, what could you do? There are lots of things, there are lots of ideas, lots of innovation going on. What could you do? What could you now do with this kind of data? And it uncovers for us optimization potential, and it helps us and supports us, or also our business colleagues, particularly in better decision making, and ultimately increases our efficiency, which in turn is also a benefit for the customer. Now, obviously, there's much more. Again, maybe seeing this kind of data sparks some ideas already among some of you. We have at our end some creative teams that I'm happy to work, or lucky enough to work with. Also from our business side, they have lots of ideas. And the very new ones I'm not allowed to share yet. They fall under company secret still. So we are striving, or we think we are a premium carrier with our transports, and we are striving to be the undisputed #1 for quality. And this is one part of our service, our improved customer experience that brings us further to be the undisputed #1 for quality. Again, I'm very happy to be a part of that exciting project, but I'm here because I am lucky enough to work with great teams. Some of them are also here, and particularly with this project, we also have great support from external colleagues who also supported us greatly, the colleagues from Global DataNet. And yeah, if you want to know more about what we're doing at Hapag-Lloyd, not just container-wise, but also IT-wise, maybe some of you have seen that, and I know some came back and say, what are you actually doing with containers? So we have a booth in front of there. We are happy to share further insights. And I think there's also a cool movie. I know that the colleagues asked me to show the movie right here in this session. I was a little bit reluctant. Looking at the time, we would have gladly made it, but it is at our booth, so we have a exciting. We also give some insight how this tracking actually applied to the supply chain, and yeah, you see the containers in action over there. So this is already everything that I have to share here today, and I'm thanking for your attention. And if there are any questions late in the afternoon, I'm happy to answer.
Cool. Thank you, Martin. Interesting talk. As a hardcore mechanical engineer, I love seeing stuff like this at use. We do have a few questions for you. I'll go, some are coming in now. How do you manage the real-time adjustments of hard copy freight documents attached to cargo by customs and other organizations passing through various ports? This is somebody who works in the industry, definitely.
Yeah, definitely. That's even nothing to do with the talk, I guess. So real-time adjustments of freight documents and hard copy freight documents. Well, first and foremost, this year is for the physical tracking of the container. Now, I'm trying to answer the first one, so the customs department is not really my expertise. I'm in the equipment side of things. I think once the transfer is started, I think there are only so many changes you can actually do, especially when it comes to the freight documents, because as far as I know, but I guess the person who stated this question knows more about that than me. There's some sensitive things. So, to be honest,
maybe visit the booth.
Yeah, maybe somebody is there who could answer it. Yeah, let's try that. Sorry for.
Yeah. Good.
Yeah, the business case.
How about the business case? Is it beneficial for Hapag in respect of operating costs?
Yes. So yes, as you could have imagined. Again, I have this device here, and who's interested can take a closer look at the box. You can imagine that this is not cheap, and I come back to the 2.2 million containers. So take the cost of this times 2.2, and this is not yet having the IT backend and all the stuff around it ready. So yes, there's been a big investment, and you can then make sure that we have some business cases. So. There's once the commercial part. Now, I told that we give away for our customers that do the end-to-end, the live position for free, but obviously we will extend on that. There's time of arrival. When does a cargo arrive? And I think we will ask the customer to give a little bit of his or her money to us for that additional service. Now, that's a big business case, of course. Now, he has asked about the operational costs. Again, the productivity, knowing when the containers are back, that is one part. We also have this, for instance, for our, also with a dry container, if a container doesn't make it to the terminal, we can replace it with different shipments. So if you're late, another container will be managed there. So you can do much more planning if you really know also internally when the containers arrive at the terminal. And we also have a case with our reefer containers where we actually do the pre-trip inspection, where we have to read the parameters of the devices of the controller at the reefer, and we can do that remotely. So they are further on. So there are plenty of cases. Just some examples thrown out there.
How do you maintain connectivity for container data while they are at sea? I think you touched a little bit upon this.
Yeah. So currently it's there are two things. So you need to distinguish where do you actually, or for what purpose do you need the data. So if the container is on the vessel and it's a big vessel, we know our captains and our fleet colleagues, they know where each vessel is, and I think there are apps out there where you can track the ships. So if the container is on the ship and we know where the ship is, we also know where the container is. Now, there are use cases when it comes to the cargo condition where the crew likes to know about that, and there's something we are investigating, connectivity on a vessel. And yes, our vessels also have satellite communication, and we can actually bring the data back. It's still something that we're working on, so there's exciting topics ahead, I guess.
Interesting, yeah. Just took up one. Have you already considered using blockchain technologies like VeChain? If yes, do you also already have a POC?
So we had some investigations into blockchain technology and how we apply that, and there have been some initiatives as well, but sort of they died down because it takes quite like the whole industry to join on this. I don't have the exact details on that. I would state currently it's a little bit on the back burner with regards to blockchain.
I'll give my opinions later. Which architecture is running on containers, high level, ESP32?
I think, or the microcontroller, I think it's a, no, is it an ARM? I don't know. Don't know.
Check the booth.
Yeah, check the booth. No, I think they will revert that back to me. So actually, I don't know. It could be that in the different devices, they have a different microcontroller architecture, depending also maybe on the complexity. If you think about the reefer devices that have to also connect to the controller and stuff. So I don't know currently, to be quite honest.
It could be proprietary as well, because you said they're specifically made for.
Yeah, obviously these companies that we do, they have like a basic layout preset, but since we have certain security standards when it comes to the hardware that we put on the ships as well, there are other constraints as well that we have to comply to.
Next one's quite interesting. How do you upgrade or do updates for 2.2 million orange box IoT devices? What are its challenges to maintain it?
Yeah, oh, that's a good one. Yeah, so first I'm happy that the 2.2 million stuck. So when I saw the slide and said, dang it, there's the mistake. So we managed that. Now, updating the firmware, obviously there's some over-the-air updating when it comes to the software updates. We can do some over-the-air updating. Obviously, they also have a sleep mode, so we have to be very careful with that. Also, some hard lessons we learned on that front. Yeah, they do it usually in waves, not all at the same time, but they have like a schedule how they update the firmware, and obviously only if the container is sitting in the depot and not being in an active transport. And yeah, it must be planned, but I think we are able to do it. Again, the device and the sort of firmware come from our providers. Obviously, we discuss and plan it with them, but they are then the ones executing it. Doesn't mean that there are challenges, by all means.
Yeah. What languages are used for the applications running in the setup?
Yeah, so the cloud setup that we've seen there, basically there's not too much business logic in that particular, and sorry for using the term platform, it's a bit overloaded. So in this cloud setup that you've seen there, I think they are basically the lumpers. I don't know if these are some scripting, some Python scriptings, I think. And then obviously we have other layers which are then Java applications that sort of retrieve the data and put them into bigger context, and also then make them available through APIs to our customers. Obviously there the checking if the customer is eligible to see his or her data or to see that particular data for that transport, and also obviously if we display it on our website behind our online business, there's a Java backend working on it, and I think we have a website, I think in React, I guess.
Cool. Interesting one, because you talked about Lambda only being $45 a month, but what are the monthly costs for the whole AWS environment?
Yeah, I think we are at around about, so across all environment, because obviously we also have a test environment and the development environment. I think we are currently running about 12,000 per month. There's also some backups in there. There's also so we have quite a lot of backups to be honest, because we have the AWS backup, we have another backup, and then the third backup. For some reason, we have the backup with our colleagues, so that added quite much to it. So we could be more cost efficiently, but currently around about 12,000 a month.
Yeah, just a few more. What are the containers running? The software containers?
Yeah, this application, and that's a bit of a pity being at the containers, this application is not containerized, it's just cloud native implemented there.
And where are they running? Is it on AWS?
Yeah, AWS, sorry, that was a small AWS logo, so sorry for.
Do you give customs access to container locations and data for government institutions? A bit of a loaded question there.
It's a good question. No, it's a fair question. So obviously we cooperate with governmental institutions and these things, but it all is channeled through our data protection office. So we make sure that we are compliant for our customer when it comes to their personal transport and where their data and the whereabouts of the transport go to. But obviously there are cases where authorities have the right to access the data, and this is carefully checked by our data protection office.
Cool. Yep. We don't want to touch that with a 10-foot pole when it comes to data management with government.
Yeah, it's things you have to face when you make quite new things.
Yeah. What's the spec, memory, CPU storage of the IoT device attached to containers? I love these questions. They're specific. And engineers.
Yeah, so I guess 4 years ago I could answer this, and I have forgotten again. There are several devices. I have to pass on that one for now.
Fair enough. Are those IoT devices running containers?
No, I think this is just hard-coded firmware.
Yeah, usually it's running C or C++ or something like that.
Yeah, and compiled against whatever processor is in there.
And we kind of answered what is the cost of the non-Lambda cloud components.
Yeah, but I guess.
Cool, that was the last question we had, I believe. Thank you all.
Coffee
Again,
break.
thanks, Martin.
Yeah. Thanks to my team.